Hello everybody, my name is Eric, and today we're going to be talking about Google's plan to fix Windows' bad security. So infostealers are arguably the most important thing in malware right now, and infostealers are almost exclusively a Windows problem. If you have access to Hudson Rock's Cavalier, you can see that about 98 to 99% of all stealer logs are on Windows. Windows is about 50 to 80% of computers, depending on industry. So there's clearly a disproportionate trend there, no matter how you hash it out. So why is that? It's not because it's not worth writing infostealers for Mac. It absolutely is. It's because the function that protects data, if you can even call it that, on Windows, as I showed in my user mode infostealer video, is very insecure. And that's what Google is aiming to fix by stepping around it. But first of all, let's just look at what's wrong with this idea. So Windows has a function. It's called crypt protect data, and it's in the DPAPI header. The way it actually works, it calls a DLL, and you can put a data blob, which is essentially a pointer to a bunch of data, in, and you get an encrypted data blob out. There's a second function called crypt unprotect data. There are no special privileges required under most circumstances to use either of these API. Now, every operating system has something roughly similar, but what Windows doesn't have, and what the core problem in the infostealer context is, besides the fact that the encryption here, to my understanding, is understood, and if you have someone's Windows password, even if you don't have their computer, you can also exfiltrate that way. The obvious problem here is there is no between app. There is no attempt at security between apps. There is no rule that Discord cannot read Chrome's cookies, and there is no rule that Chrome cannot read Discord cookies. Because, like many things in computer security, how computers are used and what security problems exist change over the decades since this API was created. So what Google have done is what makes sense, which is basically the first thing Google has done, and this isn't enough on its own, but it's a good start. If you've ever watched one of my videos, basically every infostealer is distributed with a 1234 password, and that is so that it cannot be scanned until you extract it, when the social engineering technique of disable your antivirus is more likely to work. Google Chrome now warns when downloading risky password-protected files, provides important alerts with more information about a potentially malicious download file. The more important thing they have done is actually put effort into making it so that other apps cannot read Chrome cookies. Now, the other thing they've done, and they will talk about in here, is that they have also made it much more difficult through other means to session steal Google accounts no matter what browser you're using. And I can confirm this is true because I just happened to have some Discord conversation with an infostealer developer because I was curious if he knew anything about the trend of stealing YouTube channels to spread malware, and he told me that pretty much info-stealing Google accounts is now so tricky that most people in the stealer game don't even bother and just go for other things. So they have definitely succeeded at making that very tricky. Chrome secures sensitive data like cookies and passwords with the strongest techniques the OS makes available to us. On Mac OS, this is the keychain service, and on Linux, we use Kwallet or GNOME libsecret. Now, there are issues with GNOME libsecret as well, although I don't think it's quite as bad as DPAPI, and Mac OS has a really good system of app sandboxing by default, where an application cannot access another application's folder, or any folder for that matter, without you clicking allow, which stops most of this without you intentionally clicking a lot of prompts. So, Data Protection API protects data from other users on the system or cold boot attacks. That is true, it does. That is what it is designed to do, because that was the security paradigm that they were worried about when Windows NT was designed. What it doesn't do is protect against malicious applications able to execute code as the logged-in user, regardless of admin status. That's the big problem. Infostealers take advantage of that, yes. So they are improving the DPAPI, which really means that they're adding their own security. Chrome will achieve this by adding a user mode service, not a kernel driver, that will be monitoring this. So it'll be cookies first and then everything later. So here's how it works. Elevated service. Cannot do. Cannot do. cannot do. So any of the ways that Infostealers could currently exfiltrate data from Chrome are gone without admin. And even with admin, no currently developed Infostealer will work on Chrome without a total rewrite, because what they would need to do is either bypass or disable this service. Now, there are still weaknesses here. Now, I thought about this a lot, and essentially the only way without Microsoft creating an app-level API that could potentially work off of only allowing applications signed by the same publisher to use said API as and access the same data, without doing something like that, the only way of truly protecting would be a kernel driver. Google, I imagine, does not want the responsibility, drama, and fear that publishing a kernel driver would entail. But this is definitely a big step up, especially in the enterprise where users are unlikely to have administrator access. Now, at minimum, they're going to have to, if you do have administrator access, convince you to elevate it, or they're going to have to inject code into Chrome, something that legitimate software, obviously shouldn't do, and things like virtualization-based security will make more difficult. And this is another really good change, because as I have seen most Infostealers, there are a few that are persistent, but a lot of Infostealers really rely on stealth. They will be one and done, and they will delete all evidence of their existence the moment they are done, so that someone may, especially in an enterprise environment, may genuinely not know that a hacker has every single piece of information. And one other thing they point out, although the trade-off in my opinion is definitely worth it, is that this will break any scenario where cookie copying is being used for non-malicious reasons. Another one that some people pointed out on X is that certain apps that I am not allowed to say the name of on YouTube, which interface with various companies' APIs without permission, with your cookies, will also, some of those would use a method that was equivalent to session stealing, and those will also stop functioning. Developers of such tools will have to find ways around that. What I think is going to happen, it's just my prediction, is given we have now changed the dynamic for the better, we've gone from Infostealers need to be detected and treated as malware to Infostealers are now a security problem in the app that is being stolen. Therefore, any bypass is going to actively be subject to security updates. That's a huge change, and that is going to make this way more difficult in the future. What I think is going to happen is Infostealers are going to move into extensions, because extensions do not require root privileges, and even with Manifest v3, to my understanding, a Chrome extension, at minimum, always has a persistent cross-site scripting capability. So I think we're going to see a lot more Chrome spyware and a lot less Windows spyware, which, in terms of net harm to users, is an improvement. The sneaky trend of Infostealers hiding on your system, stealing sensitive information, and causing massive damage, along with similar types of malware, is probably finally at an inflection point. It's gotten so out of hand that companies are now finally doing something about it. So that is going to be all for me for now. Please leave a comment if you have any thoughts on this, and also I might try and make a video where, and I'm not going to distribute the kernel driver because signing is a nightmare on Windows, where I attempt to make a Windows kernel driver to make this truly impossible, mainly as a proof of concept, because anything I could do with a kernel driver, Microsoft could eventually do with an API update and finally put Infostealers truly out of business. That's all for now. Bye.